right, so we're going to do some perimeter and circumference today. So I know you guys learned a super handy shortcut for figuring out the perimeter of weird shapes like this. We're just going to use it because it makes life a lot easier. So if you guys notice, we have that the bottom is 15. So that also must mean that this stuff right here that connects across the whole top must also be 15, right? 4 plus 8 plus 3 is 15. You don't have to do that, but we know that this whole top section is always going to be 15, right? Does that make sense? I'm sure you guys have I've heard around the block that you guys learned this shortcut. It's really nice. We just know the top is 15. So now what we're left with to add for the perimeter, we have both of this left and the right side, which is 9 plus 9. We have the whole top and the whole bottom, which is 15 plus 15. But we don't want to forget about these little pieces right here. So we still have plus 5 plus 5. Plus 5. So we could have added just all the numbers, but the shortcut makes life a little bit easier. What we end up getting when we add all those things together is 58 units. And this is what we're saying. There's no units given to us, but just for good practice, we're just going to do units. Okay, now circumference. So we all know that this little section that takes us to the middle of a circle from the outside and straight into the middle is the radius, right? And then the whole distance across is the diameter. Now for circumference, circumference is like the perimeter of a circle, right? So this is sort of a fun fact. Pi is the exact number of times the diameter goes around the circle. You don't need to remember that, but that's kind of an interesting way to think about it. Approximate pi is 3.14, so if you don't have a calculator that has a pi button, you'll just want to type in 3.14 for your pi. So that's really hard to see on the bottom. Circumference is d pi or 2 pi r, which makes total sense, right? Because d is the same thing as 2r. So we have a radius is right here. The diameter is all the way across. So that's 2 radii, whatever that would be. So this says circumference is d pi or 2 pi r, whichever works better, whichever you prefer. I would star that, box it, something. So, I mean, you guys probably already know that, but that is an important formula that we'll be using a lot of. Okay, perfect. The radius of a circle is 3 centimeters, and we want to find the circumference. So which circumference formula do you guys think we should use for this guy? 2 pi r, great, yeah. With stuff like this, you guys can just cut it out. C equals 2 pi r. So remember, in our homework, whatever we're doing, we always want to start with the formula. So circumference equals 2 pi r, and our radius is 3 centimeters. So we're just going to plug that in. C equals 2 pi 3. So we're going to do 2 times 3 gives us 6 pi, which equals approximately, you can type that into your calculator, 18.850. Whenever you guys round, go ahead and do it to 3 decimal places. And then don't forget our units. We have centimeters. This one below, we have the circumference of a circle is 24 meters. So this time they're giving us our circumference. They're giving us the left side of our equation. Find the radius of the circle. So I think we're going to use the same equation will be the best way to do it. 2 pi r. And this time it gives us their circumference is 24 meters. So we want to plug in that 24 for C. 24 equals 2 pi r. So we want to solve for this guy, right? So what should I do to both sides of this equation to solve for r? Yep. We can start by dividing by 2. Good. Divide by 2. You guys are going to want to show all your work for this stuff. Especially with these pi's in here, it can get confusing if you just try and go all the way to the end. Pi r. But we still have this pi attached onto our r. So how can we get rid of this pi? Yep. Yeah, perfect. We divide by pi. We could have In this step, we could have divided by 2 pi. Just be super careful with the parentheses in your calculator when you do that. You want to do divide by parentheses 2 pi and then close parentheses if you're doing that in your calculator. So what we end up with is r equals 12 over pi. Where did our... Yeah, that's good. So 3.82 approximately.
So you guys, when you're taking a test first semester, you won't get a calculator and you will leave your answer at 6 pi. So you don't even have to multiply by 3.14. You'll just leave your answer like this for all of first semester. But on your homework, because you'll have a calculator in your homework, I want both answers. And you may use a calculator, and when you use the calculator, use the pi button. Don't use 3.14, right? It's a little different. So when you're checking your answers in the back of the book, you're going to have a tiny bit different answer because the book uses 3.14 and you're using a calculator. Make sense? So don't mark it wrong. If you're close, you got it right. Okay? Yeah. No, you should get a calculator that has a pi button. Yep.
Unless you want to memorize, like, that would be fun. Don't do that. We don't have that in our room somewhere.
Let's set that really far.
Yeah. Okay, moving on. Okay, so we want to find the perimeter of this figure. So we're going to have to do a little bit of investigation on this one, which is fine. So what we know is this radius right here is 4, and this radius over here is 5. So we probably want to start by labeling, if the radius of this circle is 4, that means each of these little dotted sections is also going to be 4, right? Same with over here. 5 and 5. Okay, so what that tells us for this whole length and the height of this whole rectangle, we have that this side over here is going to be 10, right? Because we have 5 and 5. So that's 10. And then this whole length on the bottom of the rectangle is going to be 4 plus 4 plus 6. So that's going to give us, anybody? Nice, 14. So that whole thing is 14. Forgive me for the really bad not straight line. Okay. So we know this, and now we want to figure out what these rounded lengths are, right? Because we want to know about these circles, because this is also part of our perimeter. So we need to know this distance and this distance. You guys will notice that this is going to be half of the circumference, right, of a circle, and we did those circumference formulas. So if we want to do half of it, these sections are going to be 1/2 2 pi r for that part, and then this is also going to be 1/2 2 pi r. So you guys will see, yep. Yeah, exactly. So this would be the same, this is the same thing as 2 pi r divided by 2. The convenient thing for either one of them is that when we just want half of the circle, the 2's just cancel out to be 1, right? 2 divided by 2 is just 1. And 1/2 times 2 is just 1, right? So basically what we get is for these round parts, these half circles, semicircles, we get pi r and pi r. So now we're going to write out a big formula at the bottom. We're going to say P equals, we want to add all these portions together, right? So we're going to say, how do we want to do this? Do we have to, Ms. Weber, do you want them to write out like side 1 plus side 2?
No.
Or can I just put the numbers? Okay. So I just want to make sure you guys get all the steps in on your homework. Okay, so we'll start at this point right here, and we'll move around this way when I'm writing this. So we'll start with 10 plus 14 on the bottom, and then we're going to have plus pi r, and we can go ahead and substitute in that r. So the radius on this semicircle is 5, so pi times 5, and then we have this portion right here is 6. So we're just working our way around this whole shape so we get all the parts. In the top we have another pi r, but this time our radius is 4. So always make sure they're not going to give you always circles that are the same, so make sure you're looking at these separate, different radii, I think is what it is technically. So what we're left with is 24 plus 6, so that's 30, plus 5 pi and 4 pi, so 9 pi. plus 9 pi. So from this point right here, this is where you could leave it on your test. Just your units. We have feet. So we have feet. But on your homework, this right here is where you'd want to plug it into your calculator. And what I got when I plugged this into my calculator was 58.274 feet. Does that make sense, you guys? When you have your calculator for your homework, just always plug in from this point and give us the decimal answer, 3 decimals out. But on your test, we don't want you to have to do long multiplication all the time, unless that's what the problem's for. Everybody good? Just work your way around. Yep. Woo. Oh, okay, yeah, 30 plus pi 9. Yep, with the units, so we put feet on there also. You'll want to put the units on there. Okay, so now we're on to lesson 4. So you guys, usually when we do one lesson, we would be done right there. So we're not always going to have to do all of this stuff. Okay, so can anyone tell me what the natural numbers are? Any ideas? Yep. Perfect, just the regular counting numbers, not including 0. So I'm going to do some set notation. Use squiggly bracket, 1, 2, 3, 4, ... Everyone gets the picture, right? Just keep counting forever. How about the whole numbers? There's one number different. Anybody know what number gets added? Yep. Yeah, perfect. We'll do it again. 0, 1, 2, 3, 4. ... forever. Pretty good? Okay, now the integers also are always going to be, there are no fractions or anything like that, but now they include the negative numbers. So this set notation is going to be a little weird. We start with a ... and then we'll start with -3, -2, -1, 0, 1, 2, 3. So the ... means we're going forever in both directions. Okay. The real numbers are all integers, so all of these numbers, negative and positive, and fractions or decimals that can be written as fractions. Fractions and can be written as fractions. So what this means is we can't put things like pi in real numbers because pi goes on forever and it can't be written as a fraction. So like 0.2 is a real number. That's because it can be written like 1/5. It can be written as a fraction. So they're just things, sort of definition-ish type of things that you'll just want to keep in your notes. Okay, now multiplication and division of fractions. So can anybody tell me how to multiply these fractions? Anybody? Yep. Yep. Well, so we multiply straight across. So we're going to do 4 times 7 and 5 times 5. So 4 times 7, 28, divided by 5 times 5 is 25. Now we always want to think, can we reduce this at all? I don't think we can. What we can do is we can pull out a 1, right? Because 28 over 25 is more than one entire thing. So 25 can go into 28 one time. So we can take out an entire part, an entire whole. And then we're left with 3 parts left over, right? My guy is what happened to me. Oh, there we go. Okay. We have 3 parts left over. So 3 over 25. So we took out 25 25ths, and we are left with 3. So your final answer for this guy should be 1 and 3 25ths. Get rid of that. Okay. Now, how about division of fractions? Yeah. Cross-canceling, I guess is what you would call it. But we want to do something with these fractions before we do that, because we're trying to divide them. Yep. Reduce. We do want to reduce them. What do we want to do first, though? Yeah. Sorry, I'll learn you guys' names, and this will get a lot easier. Yep, in the back.
So you take the integer of the second fraction, and then the integer, that fraction flipped over, and that's what you get. That's what you get as the multiplication problem, which then you can use to use out.
Yeah, perfect. Except I think the number you're looking for was the inverse. So we flip the fraction is basically what happens. Yeah.
Copy dot flip.
Perfect.
Copy
Yeah.
dot flip.
Yeah. Dot flop, whatever. Basically, the gist of what we want to turn this into a multiplication problem because that's much easier than dividing. So we turn it into multiplication and we flip this end fraction. 8 over 15. Perfect. Okay. So now we can multiply it right across. I don't see any sort of reducing that we can do right away. So we're just going to multiply across. So 4 times 8, 32 over 45. Okay. And that's our final answer. I don't see anything that we can reduce. And we also have less than a whole, so we don't need to pull any whole parts out. Okay. However, this one I do see some reducing that can happen. I know a lot of you guys were really pumped about reducing, so now we can do it. Yep. 3 and 30. Yep, I see the same thing. So what goes into both of them? Yep, 3, yeah. So if we do 30 divided by 3, we can cross this guy out and turn it into a 10, right? 3 divided by 3, this crosses out and just turns into a 1. We could have also done the same thing with the 30 over the 9, just in case that's what anyone was thinking. So now we can multiply it across. 70 over 9. This time we have lots of wholes we can take out of here, right? So how many times does 9 go into 70? Yep. Yep. So this equals 7, and how many parts do we have left over? 7, yeah. So that'll turn into 7 and 7/9. So you do always want to turn your number into the mixed number at the end. Okay, you guys will have plenty of those to practice. So here's sort of a more complicated one. So we can do lots of canceling out, though, to make this problem a lot easier. So right away I see both a 5 on the top and the bottom. So we can just turn these into 1s. 5 divided by 5 is the same thing as 1 over 1. I also see that we have this 3 and the 6, right? So 3 can go into both of these. So we can do 1. 3 goes into 6 twice. So now we can just multiply it across, and we'll see if we can do anything from there. So 1 times 1 times 21 gives me 21, right? 1 times 2 times 23 would just be 46. Now, 21 over 46, I don't think reduces at all. So that's our final answer. Now this one, so when we add and subtract mixed numbers, we can add the big numbers and we can add the fractions, right? Now can we do that when we're multiplying? Is that going to give us the right answer? No. So don't do 2 times 5 and then 1/2 times 1/3. That's a big no-no. So we want to turn it into an improper fraction first, and then we multiply like we were on those other ones. So we're going to want to rewrite this guy. We're going to do 2 times 2 plus 1, right? That's going to give us 5 over 2. You guys can kind of do like little arrows, I think is what I do. So this one is multiplication, and then you add it, and then it goes on the top. So 5 halves. We do the same thing here. We'll do 5 times 3, which gives us 15 plus 1 gives us 16 over 3. I see some cancellation, reduction sort of stuff that we can do on this one, right? Yep. 2 and 6, right? So 2 can go into both of them, so we'll do 1 and 8, right? Now we multiply across. 40 over 3. Now how many times does 3 go into 40? Yeah, perfect. So this equals 13 and 1/3. Okay, so we're just going to do this one fast. So 37 thirds.
You have to make them improper, right?
Divided by 13, 6, yeah. And then we're going to turn it into copy flop, is that what you, dot flop?
Copy dot flip, right?
Copy dot flip, okay. Times 6 over 13.
And you guys know how to do this, right? Cross cancel, everyone got this? You just did a bunch of those just like that, right? And the next one's the exact same, right? That division sign means the same thing, right? Which one are you gonna actually make an improper? Which one do you flip? The bottom one, right? So you copy the top, right? Then you're gonna flip the bottom, and you make them improper. So you can skip a few steps, right? All I really need to see would be the first fraction, the dot, and you don't even have to do that step. You could just put times 5/11 if you want to, okay? Most of you guys know that. All right, cool. I just wanted to know like 20 minutes here.
Okay. Equal sign, not equal sign. I think we're all good on that. Okay. So operations with decimal numbers. So sometimes we will make you guys do these monsters by hand. They're really not that bad. For addition, the important thing to remember is you want to match up the decimal point. So always put the decimal point in the same spot. So if we do 4.0016 plus, because it tells us to add, 0.02163.
So you guys, we don't need to do this one, but yeah, what do you have to fill in right there?
Zero.
So really important that you fill in the zeros and that you line up the decimals. After that, you guys can add, okay?
Yeah. Just add down, carry it over, all that jazz. Same with subtraction. This is sort of worded kind of strange though. So when it says subtract 0.02 blah blah from 4.0016, which number is going to go on the top of my subtraction? Yeah. Yeah, so you're going to do 4.0016 minus 0.02. Same thing, you want to add up or line up the decimal point. It's important. 0.2163. Okay. And there's some complicated borrowing stuff, so hope you guys will get a little bit of time for homework, and if you guys want a little bit of a refresher on borrowing, you can ask either one of us and we'll help you out, just because that problem takes a little bit of time. Now multiplication is a little bit different. You don't have to line up the decimal places in this one. We worry about the decimal points in the end.
Which one should you guys put on the top? Just a quick question. Which one should you put on top of why? Caleb? Yeah, the 406 because if you, this has like more digits multiplied by, this has less digits multiplied by. Okay? So put the one that has the more on the top. Okay? And then the only thing you really need to remember is don't line up decimals. Just to speed this up, we're not going to do this one. The only thing you have to remember is where the decimal goes at the end. You guys probably know how to multiply. The one thing that people forget is where the decimal goes at the end. So who remembers where it goes? How many spaces over 80? Yeah.
Yeah, because we have 2 decimal places here and then 3 for this bottom number. So when I'm going to get some number down here, right? You put your guy right there. You'll go 1, 2, 3, 4, 5. Yeah. Again, if you guys want some extra help with that, feel free to come in because we're happy to do a full example. But
this is so much review, that's why I just want to review it. And
divide.
It's important that you do one really important thing.
Yeah. So we'll start. We put our little division house guy or whatever you guys want to call it. 0.03 on the outside. Divide this number by this number means we want this 6.039 inside of the house. So the important thing to do for these guys is to make sure we move over decimal places so this guy isn't a tiny decimal. So we want to move it over until the decimal place is all the way on the right. So we're going to move it over 2 sections, right? So we need to do the same thing to this one, the same number of decimal places. That means for our answer, the decimal place is going to go right there. So we want to move it over from this guy.
Yep, always make that outside number a whole number.
Yeah.
So remaining space to the outside needs to move the inside to the inside. Yep. Cool.
And then same spot up there.
Like you guys are deeply kind of Good job. All right, next one.
Okay, so conversions. I don't know if have you guys encountered conversions in like a science class or maybe another math class? Okay, good. So we sort of use the same sort of cancellation vibe as we do when we're doing fractions, because we want to get our units to cancel out this time now. So use one unit multiplier to convert 32 feet to inches. So we're going to start with our 32 feet. Right, now we put this guy over 1 because we're going to deal with fractions. Now we want to do something right here. So how many inches are in 1 foot? 12, right. So we're going to put 12 inches up here and 1 foot on the bottom. The reason why I put the foot on the bottom is because I want these units to cancel out, like when we cancel things out in fractions.
You guys, you have to show it exactly like this, and you want to show those feet canceling. You actually want to cross out with your pencil and see what units are left over.
And when you're doing this, these fractions should always be stuff that's equal. So 12 inch to 1 foot, that's like a conversion factor. That's how they should work. So then what we'll get is 32 times 12 inches.
So the back of the book actually leaves the answer like that, 32 times 12, right? But you guys are all going to use a calculator and give us the answer as well. All right. On a test, though, you should leave it like that. If but if there was one with squares and stuff like that, you could leave it like that. But always use calculator, okay? Yes. Yes. Show that one. Yep.
Okay. So here's another use one unit multiplier. So now we're going to start with 36 feet. Remember, always start with it over 1. And this time we want to put feet on the bottom. So we're going to put 1 foot. How many feet in a mile? 5280. We live in Denver-ish. So hopefully that number is easy for you guys to remember. Oh geez, I messed this up. I'm sorry, guys. So we want to put 5280 on the bottom. Yeah. Oh. Wow, you guys can yell at me if I'm doing something horribly wrong. Okay. 1 mile on the top, because mile is what we want to be left with at the end, right? Because it's saying we're converting it to miles, right? So now our feet cancel out, and we get...
Yeah, you guys, you don't have to divide that, like, in your head or on paper. You can use a calculator. Right? Some decimal
miles.
What you get.
These ones are especially important to put your units on your final answer, though.
Yeah. Let's get the next one, you guys. Real quick, though, how many centimeters are in an inch? 2.54. All right, cool.
Yeah.
What's next? Let's skip these two. Let's see if you know. Yeah, you guys know these. All right. So if you don't know any of them, write them down. All right. Most of you guys know 1 foot is 12 inches. 1 meter is 100 centimeters. If you don't remember it, write it down. 1 yard is 3 feet. Some people forget that. Write that down. 1 centimeter is 10 millimeters. Write that down if you don't know it. We just did the inches that you guys probably know these. You might not know this one. 1 kilometer is 1,000 meters. That's important. Okay, write that down if you don't know it. Give you guys a minute to copy down any of those conversions that you need. They are in your book as well. If you ever